So hello, my name is Dr. Evalds Urtans, and welcome to the episode of AI Ranch, the podcast where we try to navigate the wild west of AI that is right now out there. And usually we talk with businesses, but this time we talk with a significant researcher in the AI field, and he's not far away. He's Dr. Ricardo Vinuesa, if I'm spelled it right. And he's associate professor in KTH, just across the sea from Baltics in Sweden, Royal Institute of Technology, and specifically in fluid dynamics, sustainability research, and AI. So Ricardo has over 200 scientific publications already, and has quite citation index, right? And runs even his own YouTube channel. At the same time, to explain the difficult topics in easy language. And thank you for being here. So please tell us about yourself. How did you find your way into AI-related research? Because it seems like that you started with physics. Am I correct?
Yeah, that's correct. So I'm currently an associate professor at KTH, as you mentioned. I'm in the Department of Engineering Mechanics, working mostly on fluid mechanics, although I have many other interests. And I have been at KTH for 9 years. So yeah, some years ago, and soon after I arrived to KTH, I realized that there was quite some interesting potential of data-driven methods, machine learning, to look at problems in fluid mechanics, because fluid mechanics is, first of all, we have problems of very high dimension, so we have a lot of data. We have quite complex, chaotic behavior, and it's difficult to extract patterns, to extract behaviors that one can actually infer easily. So I thought that it could be an interesting area to try to see the potential of machine learning. And it turns out that it was the period where there was more and more methods and more resources available to scale up the deep learning applications. So it worked out quite well. It was nicely working in many fluid mechanics applications. And then later on, I got interested also in the applications to sustainability, climate. So I think it's a quite nice set of topics that one can look at with machine learning.
Okay. That's a good start. So, but originally you're not from Sweden, right? You're from Spain. Then I see that you went to US and then to Sweden. What was the journey, and like what have you learned from it, and what could you advise maybe some other researchers who want to follow your steps?
Yeah, so exactly. I'm from Spain. I'm from Valencia, a beautiful city in the Mediterranean, south of Barcelona. I studied mechanical engineering there. I did my undergrad. Then I moved to the US, to Chicago, where I did my master and my PhD in aerospace engineering. And after that, I spent 1 year in industry in Madrid before coming to Sweden. So it's been quite some different places, quite some different styles of working and let's say research contexts that are also quite different. So I really try to make the best out of each situation, out of each place. I'm trying to focus on, for example, in the US, I started doing experiments in wind tunnels. Then I got very interested in simulations, so I started to do simulations. Then later on, I got interested in machine learning, so I went into machine learning. So trying to really be multidisciplinary. I think that all these different topics are exciting and they can really help each other. They can really have nice synergies. And perhaps one important message as well is to collaborate. I really think that great research is multidisciplinary. It requires many points of view, many different perspectives, and therefore being able to harness all that potential, all that human talent is really what can help us to make relevant solutions for climate, for sustainability, for any problem that we are really facing, because those complementary views are really helping us very much.
So you've been working on research projects in multiple organizations, but you've also been in a role of student, right, in some of those organizations. And what has been the experience? How you compare the education in Spain, US, and now in Sweden? Do you see some significant differences? And what would you advise for somebody who would like to start in this field?
Yeah, that's a good question. I mean, I've been both a student and teacher in all these places, so I can compare also from both perspectives. And typically, in Spain, in the southern Europe, usually the education is a bit more theoretical, which is, I think, good when you start your bachelor to get a quite broad basics, quite some deep foundations. You don't get maybe to see all the applications and all the practical implications until later on, but having the theoretical foundation, I think it's important, and it's helping you when you're trying to do challenging problems. Both in the US and in Sweden, the education was much more practical and much more applied. So there were very nice experimental facilities, very nice tests, very nice practical sessions, quite some focus on projects and homeworks and, let's say, tasks that require communication and interaction with other people. So in that sense, I'm happy that I could have both approaches, the more theoretical and fundamental from Southern Europe, and then a bit more applied and being able to harness those collaborations. So I think that at the end of the day, different educational systems are complementary. And if you have a chance to, what I would suggest is that if you are in a particular university doing your studies and you have the chance to do a research or an educational visit somewhere and spend some weeks, some months in another institution, that's usually quite good because that really helps you to get to know another way of doing things, another perspective on the topics that you're studying. You learn a different culture, maybe you learn a different language. So all those things really, really help your development very much.
Yeah. So this is actually interesting direction of how much the theoretical and practical things should be in nowadays education, especially for machine learning and AI related topics. Because just recently we had a conversation with one of the successful large AI product based companies here in Baltics, and they are actually not taking that much importance in higher education. They even educate their own AI researchers with their own programs because they feel that this gap of knowledge that in the universities there are not many professors who have been solving real life problems in machine learning, being on hands on them and being kind of smarter in these particular topics. So what is your kind of defense maybe from the university side? Like why should young people then go and study in universities to get this path and then go into either very successful academic research or commercial research? What is your take on that?
Yeah, I mean, at the end of the day, it depends a little bit on what you want to do and what you want to focus on. It's true that in industrial settings, well, there is more contact with the actual application, no? And with the day-by-day challenges, the problems that can arise when developing and deploying an application with real data. So in that sense, the industrial experience is very, very helpful. But I would say that at the university, what you can get is a broader view and the foundations, right? You get the theoretical principles. Of course, if we're talking about machine learning, all the programs are now having very nice code development sessions, very nice applied sessions. I have my machine learning course at KTH in the Department of Engineering Mechanics, which runs every year after the summer, where we have a lot of emphasis on the practical aspects as well. But I think it gives you the possibility of attending a university course of having the theoretical principles of how things work. So if you need to develop a new application, if you need to face a challenge that has not been solved in that company, then maybe you have at least the mindset to tackle a new problem with an open mind. So both approaches are complementary. I think it's very important to have the industrial experience of solving the day-by-day problems in a very pragmatic way. But perhaps the perspective of having research and having deep knowledge to be able to develop new methods. And maybe you face a new data stream in your company, and then you come up with a new architecture that is a revolution. And you could do that because you had the theoretical foundations of other methods and other principles and how everything works. So, yeah, I mean, I would say that it's always helpful to know a little bit what happens under the hood and to have the theoretical principles to be able to tackle new problems.
It might be also depending on the type of the company. If you're working on some existing technologies, like you can take from GitHub all sorts of ready-made or Hugging Face ready-made models. Then you might not sometimes even require that deep knowledge. But as soon as you start working on something that is not already out there, it might be useful, right?
Exactly. If you need to develop something, then it's good to have the theoretical foundations quite clear in your mind.
Yeah, so I guess the businesses should also kind of evaluate at what stage they are. If they want to get to the market first, then probably use something existing, and then later you do some more extensive research. You probably would want to have somebody that comes from the academic background as well involved. And so far, what kind of key projects that we could highlight that you have been participated so far? Maybe you can also highlight if there is some overlap with commercial applications.
Yeah, so I mean now I'm running 3 large EU projects in which one has a big emphasis on machine learning and AI. I mean, the first one is my ERC. So this is a project by the European Research Council where we're trying to use deep learning in particular, deep reinforcement learning, to design flow control strategies to reduce the drag of airplanes. So this is the ERC projects are more fundamental. So even if there are airplanes involved, things happen a bit of from a physics point of view. We want to understand how to control the flow. We want to see how things can be optimized in a good way. So that's maybe the more scientific project. We have another project called RefMap, which is a large initiative, 5 million euros, with 10 partners across all Europe, including not only industrial partners, but quite some academic partners as well. And this one has to do with using machine learning to optimize trajectories of all the range from drones to airliners. So from drones in cities to large airplanes across the world. And here the idea is to minimize the environmental footprint, but also the acoustic impact of drones, minimize the electrical consumption. So being able to really harness all the physical knowledge that we have and all the machine learning experience that we have to have relevant applications. And the third European project that I'm heavily involved with has to do with cities. So we are also using machine learning to predict the pollution levels in cities and to try to improve the situation in concrete areas through flow control, through trying to control the traffic as well, and through identifying critical regions that can be acted on. So all these projects, there is a spectrum from more theoretical to more applied. And in all the cases, we try to really use data, machine learning, physics, and combine all these aspects to try to have meaningful applications.
Yeah, I've been also in a couple of the EU consortiums, and at least myself, unfortunately, not seen that well the transfer of knowledge to actual products in the commercial domain. In your experience, when you're working with seems to be like a little bit large projects, and have you seen actually that some of the research have you done came to the actual product, to the market at the end, or it's yet to be seen?
I mean, that depends, of course, on the TRL, of the project, on the readiness of the technology that you are dealing with. And these projects are starting, so they are in the phases that are a bit more on the research side. But I mean, the plan, we have actually conducted measurements in full scale in cities. So some of these methods for pollution measurement are being tested in full scale, so in actual cities. And when it comes to the drones, the idea is to of course test it with real drones in cities as well. This we haven't done yet because it's the first year of the project, but we're hoping that, depending a bit on the market, because the drone, the urban air mobility area is growing very fast, and there is quite some interest from companies, from regulating bodies. So I am quite optimistic that some of the developments that we will have for the drone project will actually be deployed in an actual setting. and having industrial partners helping us to identify the challenges and helping us to deploy these applications. This is really key, to be able to make this work.
Yeah. So, but to be honest, these kind of EU consortiums where you work together with research organizations and industrial partners or commercial partners, they usually they are quite large partners, or even if they are small, then they don't have that much of stakeholding. Then would you agree that basically this is a kind of great vehicle for European researchers to explore all sorts of practical things, but at the same time, so far it doesn't seem that these kind of initiatives actually ends up as a product in the market. For example, the partners, like if there's a large commercial partner, and this is a consortium, they would not be very open to give their own data to all members of the consortium and so on. So what's been experience of that, and what do you think, is it actually relevant to any sort of commercial applications?
Yeah, I mean, of course, all projects are different, and the different calls are targeting different levels of application as well. So yeah, I mean, I have been in more or and less successful projects in terms of being able to interact with the industrial partners and being able to deploy things. The system itself can be improved, of course, and I think that there could be in some calls even more focus on the industrial deployment, in some other calls more focus on the research, which I think is also still quite important. But I mean, I would not be pessimistic. I think that at the end of the day, it depends a little bit on the partners that you gather and the spirit and attitude that you can instill, in the group. But yes, of course, everything can be improved in terms of being able to deploy things. And it's a working process.
No, I don't misunderstand. I'm not pessimistic in that sense because, I believe you yourself are benefiting, and all researchers are benefiting from all of these programs. So this is great for researchers. I'm just thinking, what is then the benefit also for the market itself? I think maybe one of the ways that I have seen is that you can build relationships with other partners, with other companies, and then later on, after the project ends, you can keep working with them on actual commercial applications. But yeah, so let's go to the next topic. So the teams. Yeah, sure.
I think there is actually one more example here. I mean, when it comes to a product, I mean, it would depend on the project, I think, and you may be more or less lucky. But I think that at universities, we contribute with another aspect beyond the product itself, and it's the people, right? It's being able to train doctoral students, postdoctoral researchers with very, very high level of skill and qualification. And one of the EU projects where I am part of is a doctoral network. So these doctoral networks are excellent environments to involve also academic partners and industrial partners. You have typically 10, 12 PhD students that need to spend some time in industry and also in academia. And then the idea is that these people will be so connected with the industrial world that they will be able to work in a company, bringing the knowledge and the skills from academia to the companies. So in that sense, I would argue that one can actually bring in quite some added value through facilitating the transfer of knowledge and technology through these students, these doctoral students that become extremely talented and knowledgeable in certain advanced techniques. And then this can help later on companies. So at the end, being able to be competitive internationally is having talented people. And I think that's a good value, that one can get from these doctoral networks.
Yeah, so let's go to the next part. So the teams, right? You probably also have teams, right? You're not doing all of your research alone, especially if I looked at your publications. It seems that almost like a large chunk of them you are co-author, right? You're not the first author. So do you remember actually what the last publication where you were the first author?
We have coming up this month a review paper on machine learning and experimental fluid mechanics in Nature Review Physics. So I'm actually quite excited about that, and I'm a first author in that one. So I really try to, of course, I am very lucky to have a big team I'm very thankful for all the different skills and areas that they all cover. So now we are around 30 people, more or less, which is quite exciting. Also challenging, of course, because you need to be able to make the team work properly. But at the same time, I also like to do some work by myself, either a review paper or developing a new method or a new code. So I try to find some time to do things by myself. But of course, managing a team and being able to encourage and to inspire the team is also something very exciting that I really enjoy. So it's part of the academic work, I think.
30 people, that's a lot. So, but what are the kind of essential roles and the way how you operate? What is the largest project that you do? What is the roles in the project? What is the methodology? How you achieve the results in your team?
Yeah, so I try to have an approach that is very collaborative. So, I mean, I'm quite happy that the people in the group, they like to work together. They like to share things. I don't like when there is competition and people are hiding things from each other. I think that the effective way to do science is through openness, transparency, and communication. So we have several. I mean, we have, of course, PhD students, master students. We also have senior researchers, postdocs. So everybody at their level, they're helping supervise people. They're being supervised by someone else. So everybody can teach something or can learn something from someone else. So in that sense, I think that is a quite open, multidisciplinary environment that people, well, can thrive and have fun. I think that's really the key, to do science, that you're enjoying and having fun. And we have also many international collaborations as well. So that requires a lot of planning and visits and calls to make things work. So in that sense, some of these projects involve 10, 12 people, actually. So they are quite large projects with people in different locations. But we try to make it in such a way that people feel that they can contribute, people feel that they are useful, and that there is an inspiring goal for everybody.
But it's so the roles, right? So you have probably some project manager. There should be some data labelers. There should be the testers. There should be the like just regular developers, researchers in the field, in the machine learning by the trade, right? So what is the structure there, or is it very fluid? Is it like that this could be anything almost in the project?
It's quite fluid. I mean, at the end we are academics, so a big part of the group is students, master and PhD students who are getting an education. So the emphasis is that they should have an overview. They should have enough knowledge about the whole field. In their case, if they're doing fluid mechanics, if they're doing machine learning, if they're doing sustainability and climate. So there is not one particular task that they do, but they should be aware of everything as part of their education. Then they will focus on one topic and they will dig deeper into that topic. But in general, it's quite broad, quite general. We try to make it quite fluid, as you said. I mean, research projects, of course, we try to plan and we try to have an adequate deployment. But with research, you never know. I mean, sometimes you find a very exciting direction that is different from the original one. Sometimes the research takes longer than expected. So in that sense, having that flexibility is helping us. So there is not a strong hierarchy. There are not very, very clearly defined roles. But what is clear is that everybody knows what they're doing, more or less, what they're working with. And everybody has some flexibility to propose new ideas, to propose collaborations, because I think having that openness is what can really help to do nice science.
So do you understand correctly? So you don't really measure the performance like based on some methodology, like in commercial companies, like they have the like Scrum or Kanban, where they give this is your research topic. This should be approximately the result. This should be done at that time. We measure what was the effort done, and then plan the next steps. It's not like that, right?
It's not as strict because because in research you don't know exactly how things go. Of course, when you have doctoral students, we have something called the individual study plan, in which we know in the next year what we want to do, and then we have a planning every few months you need to deliver this and that. And that's reevaluated frequently because sometimes there are deviations with respect to the plan because it's research. Sometimes things take longer. Sometimes a method that you expected is not working as you thought it would work, but then you find something even better. So it's reasonably flexible. In terms of performance, we don't like to, in academia, of course, we are looking at conferences, visits, seminars, publications, and we don't want to count those. We don't want to count the number of publications or the number of presentations. It should be more about if your contribution is being meaningful, if you are doing something interesting, something that can be very impactful and can be very, very relevant. So that's a little bit how we want to measure the outcome of the group as a whole.
But okay, let's try again. Just last time, trying to push you in this direction to see if we can get something practical, useful out of this part.
Well, I think it's useful.
Let me give you
from the research point of view. What we are doing, I think, is useful. But perhaps you're talking more. No.
I know. That I'm not business. Telling that. I'm telling about the team's organization. As you say that you have 30 people team. So that means there definitely have been experiences that you can share that are very valuable in the managing people in the smaller scale. For example, let me give you a few examples from my experience. So I had a situation where I had a researcher working on at least half a year or even year on the problem, and he was under supervision, but at the same time he was working alone on the problem. And at the end, he didn't succeed with the results. As soon as we added more people to the problem, they immediately found fundamental errors in some of the equations, and then they solved the problem in a couple of weeks. So there was actually methodology years ago, maybe you have heard of it, extreme programming, where two programmers programmed on same computer when there was little computers, right? And this was methodology to ensure the quality of result and faster, right? So that's one example. Another example, people have different personalities. There are some researchers that do not listen to you when you tell them you should do things this way. So they listen, but then they do in their own way. I think might be better sometimes, from my experience, that researcher listens, do the way as we advise, and then later he or she does the extra steps in their own direction and then discover something even better, but not just discard what somebody is telling and do their own way. So do you have experiences like this? Maybe you can share how to organize work better.
Yeah, what we have is kind of thematic areas within the group. So we have people working on similar problems who discuss frequently. Of course, we cannot have everybody meeting every day because it's so many people and it's so many different projects. But we really have these subgroups that meet every week or every 2 weeks, giving updates. And that really helps if someone finds a problem in their project that can help someone else because they can inspire each other and they can help each other. So in that sense, these thematic groups really helps a lot. And at the end of the day, I think that the challenges that the researchers may face in the day-by-day operational work are better understood by other researchers in a similar position, so they know exactly what they are doing. And if there is a fluid communication between them, that really helps to make progress and to fix problems more easily. So that's something that works well for me. Also, having postdoctoral researchers who have more experience giving feedback to the PhD students or the master students because they can really benefit from the experience of the postdoctoral researchers. That also helps. But at the end, I think it's important that we are all on the same page and that we are all kind of, aware of what everything is going. And with respect to the second aspect, everybody is different. Everybody is different. And everybody has different aspects that are their passions, they're excited about something else, they're motivated differently. And then one art is to really find the key aspects that motivate everybody. Mm-hmm. And then to try to formulate projects or formulate questions. Some people, as you also say, they need more freedom. Some people need more direction. And at the end, it's a balance. No? You need to be able to because someone who is a free thinker, it's good that they can explore things by themselves also, no? Because maybe they will reach some new solution that nobody ever thought about. So it's about finding the personality of the person that you are, or the group that you are working with, and trying to adapt the project and adapt the challenges to their skills and their passions, essentially.
Okay, yeah, you have quite a number of publications and with high citation indexes. So, what would you advise be for new researchers that would like to achieve results like yours, like in not so long period, maybe, or with smart way how to work? What would be your advice for new researchers?
I think that first of all, it's important to not to rush things. So to really focus on good ideas, to spend time developing the research, trying things, coming up with new methodologies. So it's better to have one good article that you really spend time on, that you can be proud of, rather than having several smaller articles that are a bit more rushed. That's generally true for science, but also the good articles are more cited than the citations of several smaller ones. So I think it's important to try to do good things and try not to rush things. And the other thing that I have tried to do also is to try to do multidisciplinary research. So try to involve experts from different areas of disciplines, because that really helps to reach new ideas, new perspectives, new inspiration for new projects, and also leads to impactful publications. No? Because you can really have, one thing that I say is that impactful research is usually useful research. It's research that can be applied, because you get the perspectives from different areas of application that's usually closer to the product or closer to the actual application in the end. So multidisciplinary research in that sense is pretty good, because it helps you to increase the perspective of your research.
I think you also increase the reach, right? As soon as you have multidisciplinary research, let's say there are three fields overlapping. In your case, like the physics, fluid dynamics, and computational parts of the research, it gives you by default more citations, right?
If it's a good study in the three areas, yes. If it's mediocre, then you will not get much, right? So I mean that's the challenge of multidisciplinary research, that you need to be at a very good level in all the areas, right? So that's well, it also involves bringing experts, communicating with them, being able to understand with the different disciplines, the different languages. But it's fun. I mean, I really enjoy multidisciplinary research.
Okay, that's great. So similar question. So you've been, as you said, a student, and also the researcher and lecturer and even associate professor roles in different universities in Spain, US, now Sweden. What would be your advice of researchers that want to also get in these organizations that you have been in some of the permanent positions or in more depth research? What would be kind of way to get there?
Depends a lot on the organization and on the type of position. I mean, of course, there are always openings for assistant professor positions. No? That's usually a good starting point, because then you get a tenure track. So currently at KTH, in our department, we have two tenure track positions open. One on numerical methods for fluid mechanics, one on experimental methods. So that's always a good place to try to get later on a permanent position. And if you're thinking of students or researchers that want to do research stays, I mean, at the end, I think it's good to reach out and try to meet people in conferences, in seminars, in workshops. I mean, by email, the problem of email is that sometimes we get saturated with email, so we cannot read everything. But maybe social media is not a bad idea. If the people that you want to work with have social media, maybe you can reach them by social media. But I would certainly recommend, if you attend a conference and you want to talk to someone, go and talk to someone. Just do it. We are there in the conference to talk to people, to meet people, and those discussions are maybe a very good starting point to later on have a collaboration, a research stay, a visit, and even a longer interaction.
Well, so like I understand, I'm hearing that you're saying that first of all, you could apply directly, but better approach would be to build some relationship first. But what about the quality of the research? Like, what is the kind of threshold? For example, when you were studying, if I remember, University of Illinois, right? Yeah. So what would you say, like, for example, there and the KTH, or are there some like thresholds where you first need to achieve some results in the academic research, and then it's worth applying? Before that would not be even worth applying.
Yeah, I think it depends a lot on the group and the area of research. I mean, in Chicago, in Illinois, I went there as a master student first. So I did my master. I was happy in the research group, and we did good research there. So then they offered me the PhD position afterwards. But you already come with a certain delivery. No, you have already done something good. And then, I mean, if someone, KTH is something similar. I had a lot of collaboration with KTH during my PhD, so that later on led to the possibility of coming as a postdoc and then remaining as faculty. So yeah, I think, of course, if you come with something that you have done, or you prove yourself in the context of that group and that environment, then it's going to be easier, no, to interact further and to stay for longer. But that first contact is sometimes the difficult one, and that's why I think that it's good to. Yeah, I would encourage people to go and discuss and conferences in social media to talk to people.
Yeah, interesting that you're saying also that it was that you were a student first, and then they get to know you with the right people and so on. So I think that's another path. Actually, I don't think it's quite common path to get in the academic system of research when you first are a student. So that's good direction. Okay, and you're mentioning tenure. At least here in the other side of the sea, in the eastern part of Europe, Baltics, there is not much of that. So I mean, like maybe you can give also for the Eastern Europeans some information of what actually it accomplishes. Like what is kind of I would say from to kind of salary there. What is the resources available? If you do some like research on these kind of contracts in Sweden, for example.
So you're talking about as a PhD student, as a postdoc, or
Oh yeah, like a postdoc, for example, like a researcher.
So I mean, postdocs. It depends a little bit on the department, but yeah, I mean, across KTH is reasonably standard. So a postdoc can make around 39,000 crowns per month, Swedish crowns per month, which is depends because the Swedish crown fluctuates, but let's say something like 3,500, 3,600 euros per month, something like that, which is a good salary. I mean, sufficient to live well in Stockholm and to have a good lifestyle. And PhD students make almost as much money. So they are salaries that are comparable with what you would make in industry. A bit lower, but comparable with what you would make in industry in similar positions. So the focus in Sweden is that even if you're doing your doctoral studies or you're doing research, that you can have that as a valid alternative to industry because it's considered as an investment in your education and in your skills in the mid and in the long term. So in that sense, salary-wise is good. I mean, compared with industry, it's actually quite good. And in terms of resources, I mean, I can speak for my department at KTH. I mean, we have very nice experimental facilities. We have wind tunnels. We have world-leading experimental setups. We have very nice computational resources as well. So we have one of the largest supercomputers in Europe on campus. So we actually have quite some nice access to computing facilities. And also, when it comes to machine learning and data-driven methods, we have quite some nice facilities as well in Sweden, so we can access to those large clusters. And the key of a good department is when you have several very good people in different areas, that they're somehow complementary. So we are working on many problems within fluid mechanics, from the smallest scales to atmospheric flows, turbulence, stability, transition. So, and that complements very nicely with the machine learning, with the simulation. So I think such an environment where you get different people with complementary views that can work together, that's what makes a good department, I would say.
Well, it's interesting you're saying that, if I didn't misunderstood, that you say that you have comparable salaries for the researchers to the industry in Sweden, and it's about like, let's say, 3,000 to 4,000 euros per month, right? Or did I misheard you?
Yeah, around a bit more than 3,500 euros per month.
Yeah, because it's interesting that I know that in the Eastern Europe, the kind of top researchers make about the same in the industry. So it's kind of, I was expecting more in the Scandinavia and Sweden. Do you have any comment on that, or is it like right now more uniform in the whole Europe?
Well, I mean, this, of course, this depends on the years of experience. No, I mean, a postdoc probably has 3, 4, maybe 5 years after their studies. No, I mean, they're usually 30 or before 30 years old. So, I mean, for that age, I mean, I would say that that's a reasonable salary, and that's more or less what they would make in industry. But of course, having the PhD and having your postdoc later on, I mean, it really goes much higher, of course. But yeah, I mean, for the level of experience that you get at a postdoc level, and for a similar number of years in industry, I think that that's a quite reasonable salary.
That's good information regarding like if there's some companies that are thinking of building their own research teams, or that's valuable information. At the same time, of course, it's challenging as you need to hold your own people in the university and probably don't want them to wander off in commercial research. So again, let's till the end of our discussion. So where do you get your own information about the news, breakthroughs, the latest papers? Do you have some resources or some ways how you stay updated with everything that's happening with deep learning, machine learning?
Yeah, I mean, of course, I mean, Google Scholar is always a good source, no? Because then you get updates on the researchers that you follow, and then you can find the newest papers. But also social media is becoming very, very popular, and I'm using it a lot as well. I mean, people, some well-known researchers are publishing videos in YouTube, for example, talking about their latest developments and their newest papers. So that's actually helping. Of course, I don't know if I should say Twitter, because now it's X or whatever it will be called next week, maybe something else. You never know, right? But former Twitter is a good resource as well, because people write threads that summarize and synthesize the main points of their studies. And then if that's something interesting, you can go deeper into the paper and kind of get more details there. So I think it's a combination of using more classical approaches like Google Scholar with more modern social media, YouTube, and being able to, of course, assess the quality of the sources that you're using and stay up to date.
Which Twitter personalities would you recommend to follow, or at this moment it's there are many, and you can you name some?
It depends on because I work on different topics. So you're interested in machine learning, or?
Yeah, machine learning, deep learning.
For example, I follow. I mean, I follow many. I have a long list of AI, but some of the most well-known people, of course, I follow Jan LeCun or Max Tegmark. I mean, those are two well-known researchers. With Max, I have a couple of papers actually. So I have, I mean, I follow them, and that's a good way to stay up to date to what people are doing. But many.
Good. And from the promising directions that you see right now, like in the machine learning field, more than the fluid dynamics, can you name some of what you think would be promising directions to work right now, either as a research or maybe even as a commercial application?
Yeah, I think there's a lot of new architectures coming up almost every month to explore. I was actually, for example, we're using large language models to have new solutions for climate. So we're actually trying to extract information from hundreds of thousands of documents to really come up with new solutions towards climate and sustainability. In that context, of course, the transformer is an interesting architecture, but we've been doing some research lately showing that the transformer is actually, not as special. I mean, it's relies a lot on the data that you have, right? And that one might be able to demystify a bit the transformer by looking at its internal structure. So I mean, transformers are working very well in many applications, but there's many new solutions and architectures that are coming up. And I would say, generally, being able to use machine learning for scientific discovery, that's maybe the direction that is most promising and what we are actually trying to get into. So I would say trying to help machine learning to formulate the right questions, and that you can use that for scientific input. In that context, deep reinforcement learning is helping us very much. So we are able to come up with new strategies to control flows. For example, we're learning about the physics of the flow through reinforcement learning. So I think that direction of scientific discovery.
But I think it might be related that for the fluid dynamics, you can generate lots of data. At least I think so. So maybe that's why the reinforcement learning is great. But there's lots of fields where there's not so much data, and reinforcement learning is based on large amounts of data, right? So what's your comment on that? Have you seen recently any kind of reinforcement learning that works on very little data very well?
Well, I mean, you need data. But I would claim that in many scientific disciplines, reinforcement learning is helping. No, it's not only in fluid mechanics. I mean, of course, a few months ago, it was discovered through reinforcement learning a new way to multiply matrices, for example. That was much more efficient than the traditional method. And that's not a very, very data intensive situation. So actually they could formulate a problem where reinforcement learning without too much data was able to find really a new scientific development in the end. But I mean, of course, in general, one needs data. That's true. Or perhaps more than data, I would say a good simulator. I mean, you might have an experiment, an experiment where you just need to be able to interact dynamically with the system that you want to optimize. So maybe an experiment where you don't have so much, this is actually maybe something interesting. In an experiment, maybe you don't have so much quantity of data, but you have a lot of instantaneous realizations. You can accumulate data over time. And that's perhaps what is most helpful for the reinforcement learning. So finding the right problem and then being able to select the tools properly.
So to summarize this episode, what would be some of the main messages and key points you would give some of our listeners, that might be researchers looking for topics going into different directions, or maybe even commercial companies wanting to build these kind of products using technologies? Will be maybe some few key points you want to leave with this today?
Yeah, I think, it's really key to interact industry and academia. I mean, we see more and more applications of machine learning in industrial settings for using more and more data on the same architectures. If you want to really be creative and come up with something new, it's good to interact with academia so one can bring in some research. Research has an amazing impact on industry, not only through products, but also through the people. I think that's really maybe the most important contribution that we have. People with very high qualification, with very high training and motivation who can really, really make a difference in industry. And then when it comes to doing research, I think multidisciplinary research is really opening incredible potential in many areas, and being able to spend time. It's not good to rush things. It's better to do fewer articles, fewer studies, but to focus and to really do something impactful and meaningful. That's really the way to do something great and something that will make a difference.
Thank you, Ricardo. I hope that one day we will meet in person as well. You seem really knowledgeable and insightful in many of these directions.
Thank you so much. And I look forward also to meeting you one day. That would be great. And thank you for the invitation. This was really fun.
So thank you for joining this special episode of AI Ranch. And to help us reach more audience, please press like and subscribe and look at the links below where we have our own website and things we do. And see you in the next episode.